Hello ladies and gentlemen, today we're going to be talking about the median, centroid, altitude, and orthocenter. So today we're going to start with the median. So the median is a segment joining a vertex to the opposite side, the midpoint of the opposite side. Sorry about that. So it joins to the midpoint of the opposite side. The way we know it's the midpoint is there are these two congruency markers telling us that that piece got split into two equal pieces. The three medians of a triangle intersect at a point called the centroid. So the centroid has special properties. So this big piece here is equal to two of these small pieces of the opposite side of that one median, okay? And the small piece is half of the big piece, okay? And another thing is that the big piece is 2/3 of the whole median. So if we have our whole median here, we can split it up into 3 equal pieces, and that's going to make up our median. So we're going to go over some problems and make some more sense of these special properties. The properties will make more sense as you start to work with them. Just as a side note, one mistake I did make on my packet is I wrote AD instead of AP, and that's my mistake. So make sure you correct that in your packet because that helps with a lot of confusion. So number 1 says if point P is the centroid of JKL and JK is 22, so I'm going to mark up my drawing here. KN is 13 and OL is 18. Another thing that the medians do is they split the sides into equal pieces. So I'm going to mark that on my drawing. So I have 1, 2, 3 sides, and they get split into equal pieces by the medians. So KM is right here. So KM is going to be half of 22 because 22 gets split in half. So that's 11. NL is this piece here. NL is congruent to KN, so that's 13. KL is the whole thing, so if we know that both of these pieces are 13 and we combine them, we get 26. JO is this piece here, that's 18. And JL is this whole thing all together, so 18 plus 18 is 36. Next one says if Z is the centroid of triangle TUV and TZ is 60, XZ is 28, and WZ is 25, find each measure. So on this, I'm looking at whether I have my big piece of my median or my small piece of my median. If I have the small piece, the big piece is going to be 2 times that. If I have my big piece and I'm looking for the small piece is going to be half of the big piece. So let's get started. So ZV is the first one we're looking for. So we're looking for the big piece. So I'm going to take 28 and multiply that by 2, which is 56. The next piece I'm looking for is ZY. That's the small piece. So I'm going to take 60 and I'm going to take half of that, which is 30. ZU is my big piece. So I'm going to take 25 and double that and I get 50. And TY is this whole thing here. So 60 plus 30 is 90. And XV is this whole piece here. So I have 28 plus 56 is 70. Why can't I do this in my head? No, 84. Next one says if G is the centroid of triangle ACE and AG is 8, so let's go ahead and mark that up. So AG is 8, GF is 7, and BG is 5. They want us to find each measure. So GD is the first one they want us to find. That's the small piece. So the small piece is half of the big piece, which makes that 4. AD is the whole thing. 8 plus 4 is 12. Next one is CG. CG is the big piece. So 7 times 2 is 14. GE is the big piece. 5 times 2 is 10. And BE is the whole thing. So 5 plus 10 is 15. Next one says if X is a centroid of triangle RST and TU, so this one they're giving us the whole median on. So this one's going to be a little bit different. So we have 27. SW is this whole one is 18. And RV is 21. So on this one, we have to use the fact that the median is split into thirds, okay? So then we have to look at whether we have the big piece or the small piece. So I'm going to walk you through how to do this the first time and walk you through some more examples, and hopefully it'll make a little bit more sense after time. So when we have the whole entire median, we have to split it into 3 equal pieces, and then we have to see, do we have the big piece? If we have the big piece, we multiply that by 2. If we have the small piece, we just keep the 1. So let's see what we need. So first one they want is TX. So TX is this segment right here that I'm drawing in black. So we're going to take 27, we're going to divide it by 3, and I get 9. So that splits it into 3 equal pieces. I have 3 pieces of 9 make up 27. Then we look at whether we have the big piece or the small piece of the median. This is the big piece of the median. So I'm going to take that and multiply it by 2. So 9 times 2 is 18. Next one is XU, that's the other piece of it. Well, we already split it into 3 equal pieces, which is 9. And our small piece is just one piece of our median. SX is the next one. SX is a larger piece, so we're going to take the median and we're going to divide it by 3. So 18 divided by 3 is 6. And then it's the larger piece, so we multiply that by 2 and we get 12. XW is the other piece that they want. We already found that is 6. RX is the big piece of 21. So we're going to do 21 divided by 3, which is 7. And we multiply that by 2, which is 14. So next page, we're going to start with number 5. Continuing on with the notes, it says if J is the centroid of triangle DEF and DH is 51. So let me go ahead and mark up my drawing. So DH is 51. GF is 60. And EI is 57. They want us to find each measure. So first one they want is DJ. So 51 divided by 3 is 17. So then we do 17 times 2, and 7. Then we're finding JH, which is the small piece here, which is 17. We already found that. GJ is this piece here. That's the small piece. So we just take 60 and divide it by 3, which is 20. Then they want JF, which is a large piece. So we multiply 20 times 2 and we get 40. EJ is the big piece here on the green line, so we take 57 and divide it by 3. 57 divided by 3 is 19. And 19 times 2 is going to be 38. And JI is the smaller piece there, that's just going to be 19. Next problem says V is the centroid of triangle PQR. SR is equal to 21. So SR is 21. VU is this small segment here, is 8. PT is this whole segment here, is 15. Find each measure. So we're finding SV first. So SV is the small piece. So 15 divided by 3 is 5. VR is the next one that they want. So that's the larger piece. So 21 divided by 3 is 7. And 7 times 2 is 14. QV is the large piece here. I have the small piece already. So 8 times 2 is 16. QU is the whole thing. 16 plus 8 is going to be 24. And PV is the larger piece here. We already found VT or TV. No, we didn't. Okay. Oh, I found the wrong piece here. SV should be 7. That's my mistake. VT is 5, which makes PV 2 times 5, which is 10. My mistake, guys. I apologize for that. So next one says G is the centroid of triangle ABC. BF equals 72, so BF is one of the medians, is 72. AC is 64. Let me rewrite this. So that's 72. This whole side is 64. AC. GE is 27, and they want us to find each measure. So first thing we need to find is AF. AF and FC are congruent to each other, so we take 64 and split it into 2 pieces, which is 32. Next one they want is FC. So FC is just this piece here, that is also 32. BG is this piece here, so we take 72, divide it by 3. 72 divided by 3 is 24. And 24 times 2 is 48. GF is the next piece they want us to find. So GF is the small piece, which is 24. I just found that. AG is this piece here. So I already know the small piece is 27, so I double that. So that's going to be 54. And that's going to give me AG. Then AE is the whole thing, so we do 27 plus 54, which is 81. Next one says if T is the centroid of triangle MNP and TN is 16, MQ is 23, RP is 18, so that's this whole piece here is 18. Find each measure. So first thing we're looking for is QT. QT is the small piece. So we take half of the big piece. The big piece is 16, so QT is 8. QN is the next one, so that's this whole thing. 16 plus 8 is 24. QP is the next piece they're looking for, which is right here. This is congruent to this, so this is 23. MP is the next piece they're looking for. That's this whole side here. So 23 plus 23 is 46. RT is the next one. That's the small piece. I know the whole thing is 18. 18 divided by 3 is 6, which is what this small piece is 6. And TP is the large piece of the median that I just found the small piece for, which is 12. Last problem on this page, if H is a centroid of triangle BDF and DF is 50, CF, so it's this whole median here, is 42, and BH is 22, find each measure. So we want HE is the small piece, so half of 22 is 11. EF is this piece here. 50 is split into two pieces of 25 each to get those two segments, so this is 25. HF is this piece here, so this is the big piece, so 42 divided by 3 is 14, and 14 times 2 is 28. DE is this piece here. We already found that is 25. CH is the small piece here, which was 14. And BE is this whole thing here. So 22 plus 11 is 33. And the 11 came from part A. So next thing we're going to talk about are the altitude and the orthocenter. So the altitude, many of you have actually already worked with before. If you've used the formula 1/2 base times height, you've already used the altitude. So the altitude is just the height. Think of a mountain. We talk about mountains as having an altitude, and altitude is how high the mountain is. So an altitude in geometry is a segment joining a vertex to the opposite side so that it is perpendicular to that side. Altitudes can be inside or outside of the triangle, or even the side of a triangle. So your altitude can be inside of the triangle like this first one. It can be outside of the triangle like this second one, or it can actually be the side of the triangle like this third one. In right triangles, that's when that occurs. When the three altitudes intersect in a triangle, that point that they intersect at is called the orthocenter. So the orthocenter doesn't really have any congruent measures or anything like that you need to look out for, but what you do need to look out for is right triangles within your triangle. So for example, I have this right triangle inside of this bigger triangle. I also have this right triangle inside of that bigger triangle. There's also this big right triangle inside of that larger triangle. There's also several small right triangles here, here, and here. So there are 6 different right triangles inside of our triangle when we have the orthocenter. So it's really important to know that when you're dealing with the orthocenter, most of the time the problems you'll be completing are Pythagorean theorem problems, which use a squared plus b squared equals c squared. If you're not sure what Pythagorean theorem is, please go back and watch that video on that. If you have questions, message me on Schoology. So next thing we're going to do is review centers of a triangle. So the circumcenter is created by the intersection of the 3 perpendicular bisectors of each side. The incenter is created by the intersection of the three angle bisectors of each angle. The centroid is created by the intersection of the three medians in the triangle. The orthocenter is created by the intersection of the three altitudes in the triangle. A circumcenter is equidistant from the vertices of the triangle, and an incenter is equidistant from the sides of a triangle. So next page we're going to go to is actually a graphic organizer that is going to help you. I'm sorry in advance I can't flip this. I've tried to, so just kind of look on sideways and go ahead and get this copied down. So the circumcenter is created by the perpendicular bisectors. The circumcenter is equidistant from each vertex of the triangle. So the circumcenter is equidistant from each vertex. So these three segments here that I'm drawing up on the triangle are congruent to each other. So AM is equal to BM, which is equal to CM. The incenter is created by the angle bisectors. The incenter is equidistant from each side of the triangle. So in this case, XM is going to be equal to YM, which is equal to ZM. So XM, YM, and ZM are all congruent. The centroid is created by the medians. A median is created by a vertex connected to the midpoint of the opposite side. So one note I like to make on this part is that the median is split and that helps me remember that it's split into three pieces. The large piece is two pieces of that, and the small piece is just one piece of that. The orthocenter is created by the altitudes. An altitude is created by a vertex connected to the opposite side so that it is perpendicular to that side. That's all I have for the notes for today. If you have any questions, please message me on Schoology. You should be able to get through page 31 on your packet now. Again, if you have any questions, please message me on Schoology. Thanks so much for watching and have a great day. Bye-bye.